So you've just installed GameMaker Studio 2 and the scary empty project screen is staring you right in the face. Where do you go from here? I'll take you through it step by step. Welcome back to Dodgy Dodo. At the end of last episode, after we installed GameMaker Studio 2, we arrived at this page. Here you can create your brand new project file. At the top of the page we see a little message from the setup wizard telling us that we can start a new project file in 3 easy steps. First up, let's click the new button below the banner. We're given the option to start a new project either as a new blank project or we can opt for a template project. If you opt for a template, a demo game will be loaded into your new project. This can be helpful depending on where you want to start out. If you take a close look at the templates offered, you'll see that several templates have 2 versions, namely a D&D version and a GML version. D&D stands for drag and drop. These projects are designed to make use of the drag and drop functionality GameMaker Studio 2 offers. This means you can create a game mostly visually without the need for any coding. GML stands for GameMaker Language. If you select a GML template, you'll have access to all of the scripts, functions and code snippets that tie the game together. I want to start off clean without any clutter created by someone else, so I'll pick the new blank project option. As you can see, even when you pick a blank project, you'll have the option of selecting between a drag and drop or a GameMaker Language project. Since I prefer to have complete control over everything in my project, I'll select the GML project. I don't have a fancy schmancy working title for my game yet, so I'll give the project a generic name for now. I'll select a different location for my game project to be saved. I do this because I have an automated backup solution in place. If you don't, the default location is usually fine. The most important thing is being able to find your project files on your hard drive when you want to make a backup. As game projects can take a long time to create, it's extremely important to back up your files regularly. You don't want to be months into a project and either lose your files completely or screw something up inside your project and not have at least one backup before everything went to hell. After this, you can click the Let's Go button and we're off to the races. As you can see, a new blank project is truly empty and devoid of, well, anything. Let's go over the interface and see what we've got to work with. On the right side of the screen, you can see the asset browser. This is one of the most important spaces inside of the game engine. Here you'll create and organize the structure of all of the assets inside your game. They've already created a few groups to get you on your way. A new group for each type of asset in the game was created. All of these are empty for now, except for rooms. Since every game needs at least one room to run, Yo-Yo Games has already created this one for us. I prefer to group assets more by their function inside of the game instead of purely by different type of asset. That's why I'm going to delete all of these empty groups and create my own organizational structure. Nice and clean. If you're worried you may forget what type of assets you can create, don't be. When you right-click on the asset browser and click Create, you'll see a list of every type of asset you can create. There's quite a few of them. Don't feel overwhelmed. I'll explain each type of asset when we need it. At the top, we've got our quick access panel with recently accessed and favorited assets. I rarely ever use this except maybe for the room order panel and the game options panel. The room order panel lets you determine the order in which your rooms or levels are loaded into your game. This can be very handy, especially if you want to shuffle things around or insert a test area to quickly run some random experiments without disturbing the rest of your carefully crafted world. As for the rest, we'll go into detail on that much later. As you can see, you can also track the last few opened windows at the bottom. This can be useful if you got 20 panels open and you're jumping back and forth between them, which you will at some point. That pretty much sums up the asset browser, one of the places we really want to become good friends with. As you may have noticed, there's a tab named Workspace 1 in the top left corner. This is the tab for the as of yet void space in the middle of the screen. This works as you might expect. You can have a multitude of editors and workspaces open at the same time and switch between them through the named tabs at the top. There's some more handy shortcut icons and drop-down menus at the top. I'll go over those as we need them. Because I haven't yet decided what game I want to create, I'm first going to focus on general functionality. If we can create a general framework or template, so to say, with functionality that every single game needs, it might save us a lot of time in the future. For any future project, a lot of the general groundwork would already have been done, and you can jump straight into developing your platformer, real-time strategy game, or visual novel if you wish. And for now, it'll give me a way to be productive while at the same time providing me more time to contemplate the future of my project. I think that's a better strategy than immediately focusing on a specific type of game and trying to create everything around that. So where do we start? No matter what type of game you want to make, there are some things that each and every game needs. To give you a few examples, every game is interactive. This means we need to figure out a way for the player to control the action and interact with the game. This can be done through, for instance, a keyboard and a mouse, but also through other types of controllers. We can create a system that takes into account all likely different types of input and setting it up in such a way that they can be customized and remapped as needed, so you can use as many or as few of them as you see fit. This also keeps the door open for accessibility options in the future. Keep in mind that not everyone playing video games has the same type of skill, capabilities, or even physical functionality. Keeping controls accessible for a wide range of players is a must for me. We also need a way to show our game to the player. The images need to be drawn to the screen. Also, depending on the game, you may want to use different resolutions. We can create a system that can be customized for any desired resolution. We should also be able to switch between windowed modes and full screen. This way you could create either a low-resolution pixel art game or an intricately detailed, hand-drawn and animated 4K masterpiece. Ideally, you should be able to adjust the target resolution and desired aspect ratio by changing just a few settings, instead of having to recode a whole system from scratch for each and every project. Just like visuals, every game needs sound. We can create a general manager to organize and load in our different sound effects, play and switch background music, and change the volume of the sound. We may also want to set up a menu system so the player can customize and save some of the settings and preferences. If we do that, we'll also need a way to write this information to disk and save it for later. This could then also be used to save things like game progress, scores, health, inventory items, and world states. So there's a whole lot we can do before even deciding on a general game genre. Since this is general, non-game specific functionality, I'll start off by creating a new group for this named System. Inside of that, I'll create another group called Boot Manager. The idea behind the Boot Manager is that it will make sure that all of the different options, settings, save games, preferences, and system functionality is loaded into memory before we continue to our actual game. For this so-called Boot Manager, we'll create a new game object. You may have heard of object-oriented programming before. GameMaker Studio 2 takes this quite literally. If you want to create a player, an enemy, a pickup item, or say a door, you create an object for it. This object ties everything together that makes the item function. It's basically the hub that connects all of the separate bits and pieces that make the item what it is. It also creates a convenient single reference point that you can easily move from one place to the next without having to shuffle around images, sounds, or scripts. When creating different assets, I like to give them a little 2 or 3 letter prefix in their name. This way I can immediately see from the name what type of asset it is. And since we can't use any spaces in the naming, I'll use underscores and call this object obj for Object Boot Manager. You can also use capital letters to differentiate between the words. The so-called camel case notation because of the humps created between the upper and the lowercase letters. In a long list of names, I find lowercase and underscores a lot easier to read, so that's the naming scheme I'll be using. As you create a new asset like this object for instance, it's directly opened in the workspace area. The panel on the left holds the name and gives you the opportunity to add a default image to it. This in GameMaker is called a sprite. The default sprite is mainly used to visually identify an object in a room full of diverse assets. I'll demonstrate and show you what happens if we open up the default room GameMaker has created for us and we put our brand new Boot Manager object in it. Because it doesn't have a sprite to identify it, it simply shows up as a question mark. If you have multiple of these objects placed in a single room, it's not easy to differentiate between each separate object. So let's fix that and create an icon sprite for our Boot Manager. You can click on the new sprite icon in the Boot Manager object or click in the asset browser and select Create Sprite. Let's give it an appropriate name with SPR as a prefix to identify it as a sprite. If you want to move around objects in the workspace, you can do so by holding the middle mouse button. The Sprite Asset panel opens up automatically. The default size of a new sprite is 64 by 64 pixels, which is a bit on the large side for a system icon. Let's click on the Resize Sprite and change that to 16 by 16 pixels. Since we haven't created an image yet, it doesn't matter if we do this with the Scale Image option or through Resize Canvas. It gives the same result. When you're resizing an existing image, you'll have to be careful not to stretch or distort it. If you've already created an image in another program, you can import it directly as a sprite here. But GameMaker Studio 2 also has a built-in image editor. which for the purpose of creating identifiable icons for our system objects works quite well. Click Edit Image to open up the image editor. This gives you a fairly basic Paint-like program layout. For creating pixel art, it will suffice in most cases. In the panel that opened up next to the asset browser, you can see all of the different tools. You've got an assortment of several brushes. I'll be using the 1 pixel brush for this. Underneath it, there's a panel where you can select your colors and your toolbox. This holds the different creation and selection tools. It has all needed tools like a paintbrush, eraser, fill tool, line tool, text tool, several selection tools, and more. You can also create layered compositions in this editor, which is neat. On top you have an overview for frames. This means that if you want to, you can create multi-frame animations. So if you want to create and animate a game character directly inside GameMaker Studio, you can. To be honest, I've never used this built-in image editor for animation, but I'm willing to give it a go and see how well it holds up compared to other software I've used for this. Right now we're just here to create a simple icon, so we'll dive deeper into this editor at a later time. For now we just need to be able to identify our boot manager object from a distance. Since in the olden days you needed a floppy disk to boot up a program, I thought it would be fun to create a floppy disk icon to represent this. I'll make it simple black and white to make it stand out as a basic icon. Let's dot the lines here a bit to give the impression someone wrote something on the label. Not bad, even if I say so myself. This'll do for now. We can always replace it later if we need to. Let's add it to our object and head back to our default room. We can see that our question mark has changed into a nifty little icon. This makes it a lot easier to see what's what. Let's go back to our workspace and take a closer look at the boot manager object. Underneath the sprite we just created is a reference to a collision mask. The collision mask is something we'll discuss later as we don't need it until we start creating actual in-game content. Underneath it are a few handy toggles. Visible means the object is visible on screen while playing the game. This toggle can be handy to hide an object from the player but still have it load in the background. Not everything needs to be visible all of the time. Persistent means that once the object is created, it'll stay that way unless you purposefully destroy it. This prevents an object from accidentally being erased from memory when, for instance, switching between game levels. Very handy for general background tasks that need to run continuously while the game is active. The rest of these, aside from the events panel, I'll leave alone for now. We won't need those until much later, if ever. As you may have noticed, the events panel also opened up by itself when this object was created. There's a reason for that. Events are very important in GameMaker Studio. Events are the primary way that GameMaker Studio 2 organizes the order in which code is run and executed. This means that if you want to give the object a command and run it only once at a specific time, there's an event for that. Do you want to run a line of code each and every frame of your game? There's an event for that too. This may sound a bit confusing at first, but it'll become clear as we progress. To start off, let's give the boot manager object a create event. The create event is run only once, when the object is created within the game or program. This means it's a great place to define and initialize things and rules we need later down the line. As the event was created, another panel opened up with a code editor. Here we can write our code and start defining what our boot manager needs to work with. The first 2 lines were created for us. These are both comment lines. Comment lines appear as green in the editor and are not executed as code directly. This way you can add comments, notes, and reminders that are not actually seen as code by your game and ignored when it's run or compiled. One thing you may have noticed is that the first line of code has 3 slashes at the start and the second one has only 2. This is not a coincidence. Comment lines with 3 slashes are special comment lines that include special names, tags, and labels used elsewhere in the interface. This one includes the Add Description label. The content after the description label is displayed in the Events tab. I'll change it to Initialize Boot Manager for now. As you can see, it's changed immediately, which can be very handy to give hints of the contents of each event. As we create more elaborate scripts and functions, I'll discuss more uses for these. A regular comment has 2 slashes in front of every line. These are just notes and comments completely ignored by the code editor. If I type a new line of text without slashes in front of it, the code editor tries to interpret it as code. Since this is not proper syntax, it doesn't know what to do with it. If we put 2 slashes in front of it, it turns green to signal that the editor will ignore it as a comment and won't throw an error. Very handy to leave notes for yourself and others collaborating with you. You can also copy and paste several lines of code or even a complete paragraph into your code editor. It would be fairly tedious to have to put 2 slashes in front of every line. There is a better solution if you want to hide a block of text or maybe mask a larger block of code out of your program. This way you can reserve it for later but don't have to save it in a different location. This can be done by typing a slash and an asterisk in front of the block of text. Everything after this will be seen as a comment. If you then type an asterisk and a slash later in the page, the comment is interrupted again. Everything after this will be seen as regular code. Now that we know how comments work, let's write our first line of executable code. Let's say we want to display a message as soon as the boot manager object is created and loaded into memory. We can use a built-in function for this called showMessage. As you can see, the code editor is using different colors to differentiate between separate elements in the code. The orange text showMessage is a built-in function that shows specified text as a pop-up. On the left of it, a yellow warning triangle has appeared that obviously wants our attention. If we hover over it, we can see what it wants to tell us. It says number of arguments for function showMessage expected one got 0. This means that we haven't provided the function with information it needs to execute correctly. If we click on our function name, we can see some additional information at the bottom of the editor. Between the brackets behind showMessage are 3 letters, str. These stand for string or string of text. Since this is a function designed to display a message, it's logical that we provide the message it should display. This is called an argument. Depending on the function, it can require a single argument, multiple, or none at all. We should put our message between the brackets after the function name. Strings always need to be put between double quotation marks. If we do that, the text will turn yellow, and this indicates that the editor interprets the sentence as a string of text. The yellow warning symbol disappears. Though GML doesn't expressly require it, it's a good habit to close each line of code with a semicolon. This signals to the editor that the line of code is complete and it can continue to the next line. We can leave a little note to ourselves to remind us what this code is for. This text once again turns green, letting us know that it's just a comment. Let's see if it works. But first, let's save the project by clicking the save icon at the top or hitting Ctrl S. Let's go back to our room and run the program. We can do that by either pressing the Run button in the top bar or pressing F5. We see a pop-up message saying that the boot manager was loaded. If we now click OK, the message disappears and our room is shown. In it, we can see the tiny little icon we created for our object. This is because we marked it as visible. If we close the program window and go back to our workspace, we can untick visible. If we now go back to the room, you can see it's still visible there. But if we run the program, we get the same pop-up message letting us know the boot manager was loaded. But it's no longer visible inside the room area while the program is running. This can come in very useful. And with that, we've created our first few assets, written our first line of code, and executed our program. I think that'll do it for this episode. Next time we'll dive deeper into programming and I'll provide a crash course in variables and data types, and we'll get started on our very first custom functions. Thanks again for watching. If you want to encourage me to make more videos, don't forget to like the video and subscribe to the channel. See you in the next video, and have yourself an awesome day.